Hey guys, so hi, this is Harismita. So இன்னைக்கு நம்ம வந்துட்டு matrices chapter பார்க்க போறோம். So today we'll be seeing chapter 3 matrices of class 12 CBSE. So before going into matrices, you'll be learning this concept for the first time, right? In 11th also you wouldn't have learned it, and this for 12th standard you'll be learning it as a new concept. So basically, when you take matrices or the chapter 4 also, which is determinant, both contains around 5 to 10 marks for your final exams. So this is kind of important subject, and only in this subject, only in this chapter, you can score a lot of marks. So yeah. So before going into the video, let's see what is a matrix. Like, yeah, let me tell you the brief explanation about what is a matrix. Then we'll be learning the types of matrix, order of matrix, representation of a matrix, then operation of a matrix. Let's see how much we cover for this session. Suppose if you're not covering fully, we'll be having a part 2 video of it. So yes. And yeah, as I already told you, matrix consists of 5 to 10 marks. So if anyone join, like, just tell me hi, and let me start. So okay, so yes, so yeah, what is a matrix? So generally, matrix is actually, it is originated in 1957 by author Cayley. So only this author Cayley developed the properties of matrices. Okay, in 1857 he developed it. So let's see what is a matrix. So generally, have you seen an array? So array, as in, like, first, before going into the concept as what is a matrix, let me tell you a quick example. For example, you can see a bunch of ants just walking, right? It'll be walking in the straight line. So you don't know, like, for example, if there is 10 ants, you will be able to count it. But what happens if there is n ants? Like, you'll be having a line. Basically, you'll be having a line, and that is actually called an array only. So a line, basically, you'll be having different elements. So can you see the picture? You'll be having different elements in a line. So that is actually called an array, and it is like, line is not called an array, but horizontal line. For you have one row and n columns, and that particular thing is called array. So only with this matrix has been originated. And using matrices, what are the applications of matrices is, for example, if you're taking a photo of yourself in your phone, that will be saved as a pixels. So if you have noticed it, it will be like 360 cross 520 or 1000. You'll have a pixels, right? Even in YouTube, we'll be having pixels. So basically, that is actually a matrix. So your image in your phone is saved as a matrix. It will be and the matrix order, like, let me tell you what is an order in the further classes, like, yeah, further slides. Matrix, it will be saved as a matrix order. That is called basically, here you'll be having, in your phone, you'll be having 120 cross 150. That is pixels, right? That is the order of the matrix in which your picture is saved. So matrix plays a major role in digital image processing. So for further, if you learn, like, if you go to engineering, you'll be learning a concept called digital image processing, where your images have been saved as a matrix form. So be it any image, you can take any image that is saved in the form of matrices. Okay, and matrices also helps us to find or to solve the linear equations. Like, you have linear set of equations, right? X plus y plus z is equal to 0, and you'll have set of bunch of system of linear equation. So in that case, matrices helps us to solve helps us to find the x value, y value of your linear system of, it's like system of linear equations. So these are main applications of matrices, and matrices is actually easy compared to your other subjects. Like, yeah, matrices is your third chapter and fourth chapter. I'm just combining both. Like, matrices and determinants are really easy compared to your differentiation, integration and all. So in this chapter you can score well, and when it comes to JEE or WITTI exam or SRM exam, this matrices will be combined with other chapters such as differentiation or complex number. Then combining both, they'll be asking you a question which is kind of tricky, but yeah, if you understand the concept well, you will be able to answer. So now, like, without further ado, let's quickly get into the subject. So what is a matrix? So matrix is basically a rectangular form of arrangement. So it is a rectangular form of arrangement. So basically, if you have a rectangle, you'll be having a breadth and you will be having a breadth and a length, right? So you'll have two different dimensions called m and n. For example, take your length as m and breadth as n. Same way, it is a rectangular arrangement of mn elements. So this is a rectangular in the form of an ordered pair, ordered set of m rows, and each row consists of n elements. M rows and each row consists of n elements. Okay, so this is the matrix definition. So you need not know the definition of matrix as in, like, just remember that you will be having a rectangular kind of arrangement and you will be having m rows and n columns. So each row has n elements, which is basically nothing but you will be having n columns. So this is called a matrix. How do you represent a matrix? Either you can just write it like the square bracket, or you can write it in that curved brackets. Okay, so this is how you can just represent a matrix. Okay, now when you represent a matrix, it depends on your order also. For example, like, see, if you're having let me first tell you what is an order of matrix, then let me go to the representation of a matrix. Okay, so now when you talk about order of matrix, basically in your matrix, how many rows and how many columns are there, that is your order. So basically, order of matrix is nothing but rows into columns. So your number of rows into columns is your order of matrix. So now rows into columns is your order of matrix. So now how do you represent a matrix? Suppose if you have 2 cross 2 order, which means 2 rows and 2 columns. So yeah, like, see, 2 cross 2 means what? 2 rows and 2 columns. So you will be having how many rows? You'll be having 2 rows and 2 columns. How do you represent it? So basically, there are 2 rows and 2 columns. So how many elements will be there? So in total, there will be 4 elements inside it. So how many elements will be there? There will be 4 elements. So for example, 1, 4, 3, 2. So this is a 2 cross 2 matrix. This is a matrix of order 2 cross 2. Now, what about the other one? So what about the other one? As in, you'll be having first, let me take 1 cross 1 matrix. What is 1 cross 1? Generally, you will be having just one element that will be inside your matrix. So one element means 1 row and 1 column is basically 1 element. So this is 1 cross 1. So let me write it as 5. Okay, the element inside, let me represent it as 5. What about 1 cross 2? 1 cross 2 means you will be having 1 row and 2 columns. So basically, you will be having 1 row. So basically, I write it as A and B. And inside the matrix, what all elements can be there? So inside the matrix, elements can be negative, positive numbers, any expressions. So basically, you can have an expression inside the matrix. You can have negative numbers, you can have a complex number inside the matrix. So inside the matrix, generally you can have any elements. Okay. Now let me talk about 2 cross 1. 2 cross 1 is basically you'll be having 2 rows and 1 column. So it will be like, so let me represent it like any box, either square bracket or curved bracket. So this is 2 cross 1. Okay. So this is 1 cross 1, 1 cross 2, 2 cross 1, and here 2 cross 2 means basically you'll have 2 rows and 2 columns. So A, B, C, D. So basically I'm having 2 rows, and how many columns am I having? So I am having 2 columns. So basically I'll be having 2 rows and 2 columns. Okay. So this is my generally the order of matrix. So now let me tell you how to represent a matrix. So when you talk about representation of matrix, so first let me start with 1 cross 1. So 1 cross 1 order, if you take, you'll be having 1 row and 1 column. So I'm representing the matrix as A11. So A11 basically means, so this here means your row, which row it is, and this here means the column. So which column does the element belong to? So that is how. So this element belongs to first row and first column. So I'm writing A11. So what about 1 cross 2? So 1 cross 2, if I write, it will be 1 row and 2 columns. So A11, A12. So basically when you take here, this is first and you'll be having 2 columns, right? So this is the element which is in first row and first column. First row and first column. So this is the element in first row and first column, and this is the element in first row and second column. So this is first row and second column. So this is how you represent it. Now what about 2 cross 1? So your 2 cross 1 can be represented as A11, A21. So basically how many rows are there? So 1. So there are 2 rows and 1 columns. So this is first row and first column element. This is second row and first column element. Okay. Now what about 2 cross 2? Let's see what about 2 cross 2. Okay. So 2 cross 2 is basically a 2 cross 2. So your 2 cross 2 matrix, how do you represent it? So you will represent it as A11, A12, A21, A22. So basically you will be having first row and second row. Same way you will be having first column and second column. So this is the element in first row, first column. This is first row, second column. This is second row, first column. And this is second row, second column. So, so did you guys understand this? So yes, did you guys understand this? So yes, now let's go to the next important concept. So here, what is a comparable matrix? So when you look at the term comparable matrix, what comes into your mind? You can compare 2 matrices. Basically, that is only coming into your mind. What does compare word mean? Basically, you'll be taking 2 matrices. For comparing things, you should have 2 elements. 2, basically minimum you'll be having 2 elements or 2 or more. Same way in this, you'll be having 2 matrices, and when you compare and see, basically you say a matrix is comparable matrix if number of rows of A matrix and number of rows in B matrix both are same, and number of columns in A matrix and number of columns in B matrix both should be same. So when do you say 2 matrix is comparable? So 2 matrices are said to be comparable. So when do you say that? You say 2 matrices are comparable if and only if each one of them contains as many rows as and columns as other. So for example, and this is also called as equivalent matrix. So this is also called as equivalent matrix. Now let me tell you an example. So for example, you have a matrix A, you say it as 1 2 3 4, and you have a matrix B, you say it as 2 1 3 4. Okay, so do you think both the matrix are same? No, right? So look at the first element here, you have 1. Look at the first element here, you have 2. So both are not same. But so look at the order, it is 2 cross 2. Here also it is 2 cross 2. So number of rows in A is 2. Number of rows in B is again 2. So same way, number of columns in A is 2. And number of columns in B is also 2. So now what can you say? You can say that A and B are comparable matrix. So A and B are comparable matrix. So this is called comparable matrix. Now let's quickly see what is let's see the contradiction example. Okay, contradictory example. For example, let me tell you A is equal to 1 and 2, and I'm telling B is equal to 1 2 3 4. So look at the A. What is the order of A? You'll be having 2 rows and just 1 column. So what does it mean? It is 2 cross 1 order. Here you're having 2 rows and 2 columns. So basically, the number of columns in B is not equal to number of columns in matrix A. So you cannot compare these two matrices and you can never tell they are equivalent. Okay. So A and B are not comparable matrix since what? Since the number of columns in A is not equal to number of columns in B. That's all. Okay. So number of columns in A is not equal to number of columns in B. So basically this is your conclusion. This will be your conclusion, right? Now let's see, what if you have an exact duplicate of A. See, you're having A, I have written it as 1 2 3 4, and B is also 1 2 3 4. Then what do you call? If you have an exact duplicate of yourself, what do you call it as? You can call it as equal, right? So there comes our equal matrix. If two matrices and its element inside it are exactly equal, then what do you say? It is called equal matrix. So you have two matrices. So matrices like A is equal to Aij, like elements inside it is Aij, and B is equal to B matrix is Bij. Then you say both are equal. When do you say both are equal? If the elements present inside A should be equal to elements present inside B, as well as the order also should be equal. Only then what can you say? Only then you can say they are equal matrix. So are said to be equal. When can you say they are equal? If and only if what? They are of same order. So they are of same order. What does that mean? That is number of rows in A is equal to number of rows and columns in A, or number of rows in A is equal to number of columns in A. Number of columns in B. Number of rows in A. Sorry, one second. So number of rows in A is equal to number of columns in B, right? Same way, number of columns in A, that will be equal to number of columns in B. So main important criteria for you to tell if it is equal, they should be of same order. After that, then their corresponding elements. So if your first row and first column element of A should be equal to first row and first column element of B. So their corresponding elements should also be same. Their corresponding elements are equal. So their corresponding elements are equal. That is what Aij is equal to Bij. So basically what can you say? Your Aij is equal to Bij for all I and j. Okay. So let me give you an example. So you say two matrices are equal. Let me say. So you say 1, 2, 3, 4. This is my A. Okay, this is my A matrix. Same way when you talk about your B matrix is nothing but 1, 2, 3, 4. So the first element of A matrix and the first element of B matrix is same. So first let me check the order. Order is basically 2 cross 2. Both are 2 cross 2. Then the first condition is over. Now let's go to the second condition, their corresponding elements. So here 2 is there, right? So 2, the second element is also same, the third element is also same, and the fourth element is also same. So now what can you conclude? You can conclude that A and B are equal. So A and B are equal. So what if I tell you the A and B matrix are equal? What do you conclude? You can conclude that their corresponding elements are also equal. So I'll give you an example for that also. Let me have a matrix A. I'm having it as A, B, C, D. Okay. And I'm having a B matrix, which is again what? Alpha, beta, gamma, and delta. So what can you say? And I'm saying A and B are equal matrix. So I'm saying A and B are equal matrices. So what can you conclude? You can conclude that my first elements are equal. A is equal to alpha. My second element are equal. B is equal to beta. My third element, what is my third element? My third element is C. That is also equal. C is equal to alpha. C is equal to alpha. And what about the last element? The last element D is equal to delta. So you can, if they give you two matrices and if they tell you to prove, like if they ask you basically what about the elements, you can directly say the elements are equal. Okay. Now let's quickly solve few sums regarding it. Okay. So yeah. So if I'm having a matrix. So I'm having a matrix A minus B. 2, this is same. This is single element A minus B. This is 2A minus B. This is 2A plus C. This is 3C plus D. This is equal to what? This is equal to minus 1, 5, 0, 13. Now I told that they are equal matrix. Basically I'm asking you to find the A, B and C of it. So now, as I already told you, the first element will be equal to the first element of this one. So what will it be? A minus B is equal to 1. Now the second element. So the second element 2A plus C will be equal to 5. Okay. So what will it be? So 2A plus C will be equal to 5. Now what about the third element? Third element is 2A minus B will be equal to 0. So what can I say? 2A minus B is equal to 0. Now my last element is 3C plus D is equal to 13. Okay. So this is my elements. Okay. So once again. So yeah. Now, what can I say? So, from this, let me name it as first equation, second equation, third equation and fourth equation. So, now what am I doing? I am equating my third equation, right? So, if I equate my third equation, what happens? So, it will be, I'm writing equate third equation. So, it will be 2A minus B is equal to 0 and 2A is equal to B. So, instead of I got B as 2A. So, where can I substitute B? So, look at the other equations. I have taken third equation. Look at the first equation and second equation and fourth equation. So, where does B occur? In equation 1, there is b. So, I am going to substitute my b value in equation 1. So, what am I doing? Substitute b in equation 1. So, if I substitute b in equation 1, what happens? So, this will basically be, what is it? So, a minus 2a is equal to minus 1. So, is equal to plus. Yeah, actually it is minus 1, no? I have written it. Yeah, it is actually equal to minus 1. Same way, minus a is equal to minus 1. A is equal to 1. So, I have got my A. Then what about my B? I know B is equal to 2A. So, I can just substitute that and get it. So, B is equal to 2A. B is equal to 2 into 1. What about next one? B is equal to 2. So, what can I conclude? My B is equal to 2. Are you guys clear? So, yes. Are you guys clear? Okay. So, now let's go. Let's quickly solve our next. I got my A, I got my B. Now I have used my second equation and first equation. Now let me check my I have used my third equation and first equation. Now let me check my second equation. In second equation, I have my A and C. I know the value of A. Can I find C? Yes, definitely we'll be able to find our C. So it will be 2A plus C is equal to what? Is equal to 5. And what is my A? A is 1. So 2 into 1 plus C is equal to 5. So C is equal to 5 minus 2. C is equal to 3. So what did I get my C as? My C is nothing but is 3. Okay, C is nothing but that is 3. Now let's check about the other one. Other one, I have used my third equation also. I have used my first equation, second equation and third equation. Now let me check about the fourth equation. So when I further check my fourth equation, this will be, so fourth equation is, what is my fourth equation? Fourth equation is 3c plus d is equal to 3c plus d is equal to 13, and I know what is my c value. My c value is 3. So I'm substituting my c value in the equation, which is in the last equation, right? Yeah, in the last equation, which is fourth equation. So 3 into 3 plus d is equal to 13. So now if I further do, d 9 plus d is equal to 13. So when I further do, d is equal to 13 minus 9. D is equal to what? D is equal to 4. So D is equal to 4 is my answer. Okay. So what is my answer? D is equal to 4 is my answer. Now can I label? So my A is equal to what? My A is equal to 1. B is equal to 2. Yeah. C is equal to 3 and D is equal to 4. So I have solved, I have got the answer for these things. Okay. Now let's quickly, yeah, that's all for today's session. And yes, in next session, let's learn about the types of matrices and few sums related to it. So yes, until then, it's bye from Harismita.